Dr. V. Jayalakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing cent percentage of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series, BSc Electronics Harness, Electronics Practicals 9, 8085 Microprocessor Programming. In this episode, we will discuss how to add two 8-bit numbers with carry and without carry. Now I want to add the two numbers 37 and 22. Okay. So adding that 7 plus 2 9, 3 plus 2 5. So 59. So this is our required task. Now think of what are the facilities available in 8085, how to convert this mathematical addition into programming. So first we have to initialize or load the value 37 into one of the register, with the 22 in another register, then we have to perform the addition, right. So let me recollect and write the corresponding instruction to initialize 37. 37 is a 8-bit data, right, and for addition in 8085 one of the data should be loaded in the accumulator. So I will select the first data to initialize in the accumulator by using the instruction MVI A, 37 H. The H represents the given number is hexadecimal. Then I will select the next number, which is 22. So take any one of the general purpose register B, C, D, E. I will select the C register MVI C, 22 H. Okay. So I have initialized the two data. Then what I have to do? I have to perform the addition. So for addition, we have only two instructions. One is ADD, another one is ADI. So here another data is loaded in the register. So I will select the add instruction. So add which register to be added? C. So what is the meaning of that? The accumulator is added with the C register. Then the result is stored in the accumulator. Now the accumulator value is 59. Now I want to check the answer. So to see the answer, you have to use the STA instruction. STA instruction at any one of the location you can see it. So 4300 H. So 4300 H means now the accumulator value or the resultant value will be moved to the memory location 4300, right. That's all the program. Now stop it by using the halt instruction. By executing this program, you can identify the result 59 is stored in the address 4300. Okay. So how many addresses is required for each instruction? So this is opcode, this is operand. This is opcode, this is operand. This is opcode, this is opcode, this is two operands. Then this is. So how many addresses is required? For this instruction 2 address, for MVI C, 22 2 address, then 1 address, then 3 address and 1 address. So totally 5 plus 4 9 addresses required for converting this program into opcode. Before typing into the kit, we have to convert it. Suppose I have selected the address 4200 for typing the program. Okay. So, in the 200 I have to store the first address, which is MVA. MVA is 3E. Then 4201, which is 37. So, these two instructions or these two opcode or the two address will represents the first instruction MVI A comma 37, right. Next I have to use MVI C. So, 4202, which is 0E. You refer the opcode sheet and write it. Then 4203, you write your own operand. It is not in the opcode sheet. Only this MVI C will be available in the opcode sheet. 22, whatever your own data, you have to write it here. Then increase the address 4204. Now you give the opcode value for add C. Add C is 81. Then increase the address 4205. Now the opcode for STA is 32. We keep in mind, first we have to enter the lower byte, then higher byte. In case of any 16-bit number or 16-bit address or 16-bit data. So, first I have to start 00. The next address 4207 is 43. Then 4208 is halt 76. These two address for MVI C comma 22. This is for add C. These three for STA. This is for STA. This is for address. Then this is halt. So, get the opcode sheet and clearly watch how to convert the mnemonics into opcode. If any operand is present, then it may be 2 byte or 3 byte. It represents either 2 address or 3 address. Okay. Let me start the execution of 8085 program. In 8085 program, how to use the kit. So, after switch on the kit, first we have to type the first addition of two 8-bit number, which is 37 and 22. Starting the address is 4200. So, I will give how to type the instructions. So, sub 4200. So, after comes 4200, press next to type the opcode for MVAA, which is 3E. Then press next to type the operand 37. Then press next, which is MVIC 0E. Then press next for the operand 22. Then press next, which is for add C 81. Then press next to store the value 32. Next the lower byte 00. Next the higher byte is 43. Then press next to type 76. Then next to address you clear it. Okay. Now reset it. Use sub button to take the address 4200. Press next. Now check whether the program is entered correctly or not. 3E 37, 0E 22, then 81, 32, 00, 43, 76. Okay. Now reset it. How to execute the program? Go starting address, execute. Okay. If any error comes, it does not come E. So, E comes means executed. Now reset it. So, how to view the output? Take the resultant address which by using the sub button sub 4300. So, what is the expected result? 59. So, by pressing next button it will comes, the 59 is the answer, right. This is the execution of the first program. Another example 37 and 49. Okay. So, how to add it? So, 7 plus 9, the value was 16, right. So, we cannot write as it is in the resultant, because this is a hexadecimal number, we have to convert into the hexadecimal, then write it 16 1 0, right. So, we have to write 0 here, the 1 comes as a carry. So, now the result is 80. This is a hexadecimal number, not a decimal number, right. What is the special in 8085 is if any carry occur in this lower nibbles, it automatically carry over. So, by the previous program we can execute this value also. Now, I am taking another example 85 plus 99. So, how to add these two number in the hexadecimal? 9 plus 5 is after 9, how to call it? Instead of 10, 11, 12, we have to use A, B, C, D, E, right, or simply you can add 9 plus 5, 14, 14 should be converted into hexadecimal number which is E. Now, I am adding 8 plus 9, 8 plus 9 is 17. So, 17 which is greater than 16, so I have to convert into hexadecimal number. So, the 1 times 16 remainder is 1. So, the remainder first we have to write, then this number. So, the answer is 11E, but the accumulator size is only 8 bit. The accumulator size is only 8 bit. So, in the accumulator we can store only the 8 bit data. So, what about this? We have to carry this also, right, then only we can get the proper sum of the value. So, we have to think the logic how to carry this additional value. Same method. So, when we are feeling that it exceeding the size, so after addition only. So, after addition we have to insert the logic, what is the logic behind to that. So, now we are checking the carry flag, that is if carry flag is set represents it exceeding the size or the carry is occur. If carry is occur means automatically it is not sufficient to hold in the accumulator. So, automatically we need one more register. Suppose I take it as a B register. So, in the B register 0 1 value will be stored, in accumulator 1 E will be stored. So, by using these two register only I can get the result or to address need. So, I will start to write the program how to add to 8 bit number, this may be called as with carry. So, first initialize the data MVI A comma 85H, first data is loaded, then MVI C comma 99H. Then what I have to do? Just to do the add instruction, add C. So, now these two are added, but the resultant in the accumulator is not correct, I want to correct it. So, how to correct it means, if there is no carry means I will store the result, right, store the result STA 4300H. If carry is occur, what I have to do? I have to use the B register. So, for that I have to initialize the B register MVI B comma 00H, MVI B comma 00H. If carry occur, then I am asking to increase the INR B. So, INR B means the B value will be increased by 1. Now, I am moving this B value to the accumulator, then store at the next address STA 4301H, then halt. Okay. So, we will go through once again. So, I have initialized MVI B comma 00, which is for carrying the carry value, which is used to hold the carry value. Then these two data is initialized, then added, then I have checked with the carry flag. If no carry means simply store the resultant value. If carry is occurred, then the B register is increased by 1, then that increased value is moved to accumulator and storing, because we cannot store the B register directly to 4301. Via the accumulator only we can store or we can access the memory, that is why I have moved to accumulator and store it. This same program also suitable for the previous example, but that program is not suitable for this example. Check it, how many instructions are required for this, how many addresses are required to store this program. So, for MVIB, and this is the opcode, this is the operand. So, 2 bytes, next also 2 byte, this is a only opcode. So, single byte, This one is 3 byte instruction, this is a 16 bit address. So, 3 byte instruction, this is only opcode, single byte instruction, this is a 3 byte instruction, this is a single byte, this is a 3 byte, then we have to use halt instruction single byte. So, totally 4, 4, 4, 12, 12 plus 3, 15, 15 plus 4, 19. 19 addresses are required to store this program. Now, we will convert this program into opcode. So, 4100 I will start to write the program. So, 4100 the opcode of 0 MVI-B is 06, then the operand value is 00, the next address is 4102. So, I will have to write MVI-A, MVI-A is 3E, then the operand 85. So, it need 2 address, I leave it, then next address is 4104. So, MVI-C, its corresponding opcode is 0E, then the operand is 99, then it need 2 address, the next address is 4106. In 4106 I have to write add C, add C is 81, this is single byte, single address is enough, then 4107. In 4107 I have to write JNC, JNC is D2. Then I have to write the address, but I did not know the address, so I will leave the space and also allocating the address. So, 789. Then I will write the address as 10. 10 is denoted with A, which is INRB. INRB is 04. Then 410B. This is a single byte instruction, single address. In 410B, I will write it as 32 for STA, then 0043. The next address is 410B, C, D, E, 3 address. After the 3 address, it become 410E. Now I have to write move A comma B, which is 3C. This is a single byte, so 410F. In 0F, I have to write 32, then 10S01, 11 is 43, right, 3 address F1011. Now the current location is 4112, halt, which is 76. Now I have to fill the address, jump on carry with STA. STA is here, right, 410B. So, first lower byte, then higher byte. So, you keep in mind this is the opcode, this should be entered in the kit to verify the answer. Now, we will check the second program how to execute. Addition of two 8-bit number with the carry, that is sum of 85 plus 99. So, I will take the address 4100 to store the or to type the program. So, 4200 by pressing next you can continue MVI A comma 85. So, 3E 85, then MVI C 0E 99, then I have to add MVI B comma 00. So, MVI B is 06, then 00, then use 81, then D2 00 I have given to identify the address, then INRB as 04, then STA instruction which is 32 0043, there is a resultant address, then 3C 32 01 43 76. After D2, I have to give the address 0C with 41. This is the jumping address. Then 04, 32, 00, 43, then 3C, 32, 01, 43, 76. So check the program once again, 4100, okay, 3E 85, 0E 99, 81, D2, that is MVA B comma 00, 81, D2, 0B 41, 04, 32, 00, 4300, then 78, which is opcode for move A comma B, then 32, 01, 4376. So now execute the program, go 4100, execute it, reset it, take the resultant address 4300, next 1E01. This is our required answer, right? So now we will discuss sum of 5 numbers, which all are 8-bit numbers. So how to add? So when you have a array of numbers, you couldn't add or you couldn't initialize more registers, because in 8085 we have limited general purpose registers. So better we have to initialize the memory and store the data, right. Now I will take the first 5 numbers. What are the numbers to be added? 02, 03, 05, 04 and 06. So now these 5 numbers to be added. So what is the answer for this? 2 plus 3 5, 5 plus 5 10, 10 14, then 20. So we cannot give this as a answer because 20 in the decimal number. So it should be converted into hexadecimal number. So 20 divided by 16. So 1, remainder 4. So the expected answer is 14H. So how to initialize? Suppose I want to take the memory as 4500. So in 4500 I have to store 02. In 4501, 03, 502, 503, 4504. So from 4500 to 4504 I need to store the 5 numbers. So how many data I have taken to write taken to sum is 5 numbers. So I have taken 5 numbers to add. So the 5 numbers should be initialized as a counter, the starting memory location to be initialized. So I will write the program for this, LXI H comma 4500. This is the memory initialized. Then I have to initialize the counter, which represents how many bytes. So I am taking B register as 05H. So everything in the hexadecimal number, so I have to write it as a H. So the initialization process is over. Now we have to start to add. So before starting the addition, one of the data to be loaded in the accumulator. So for that I am going to add continuously the number. I want to initialize the accumulator as 00H. That is, I am clearing the accumulator value. If any previous value, that will be removed. Now what is the logic to add n numbers? So now accumulator is clear, first data to be add. So the content of HL is called as M. So I simply use add M. So it represents accumulator value with 4500 content, that is M register value will be added and the result is stored in the accumulator. So first data is added with accumulator. Next I have to take the next data, which is 03, which is stored in 4501. So how to call 4501? By increasing the memory location. So now I am in 4501. Then the counter value was reduced. Initially the counter value B register, you take it as 05. So 05 after reducing that DCR B. So now it become 04, right. Then after decrement I have to continue the addition. So this process is repeated until the B register become 0. Now I am switch over here. So what will happen? The previous accumulator value, which is 02, with 0 0 is added, which is value is 0 2. Now the 2 plus the current value 0 3 will be added, which is 0 5. Now the counter value is reduced as 0 3. Now it is not 0. So now the previous accumulator value 0 5 is added with the increased location, which is 0 5. So 5 plus 5a is 0a, right. In hexadecimal addition 5 plus 5a become 0a. Now the register value is decreased as 0 2. Already the memory location is increased as 4503. So the counter value is not 0. Now I have to add the previous result 0a with the current location 04. Actually a plus 4 is b, c, d, e, right. So it become 0e. After that I have to do increase the memory location. Now it become 4504. Then decrease the counter, which is 0 1. Now it is not 0. So again I have to add with previous result 0e plus the current value 06, right. 0e plus 06. So e after f, after f what comes? 10, 11, 12, 13, 14. So the answer is 14. That is after 0e it comes as 0f, it is like a 9. Then it comes 10, 11, 12, 13, then 14. So these 6 numbers are added. So finally you get 14H. After that the address is increased as 4505. Decrease the counter, this become 0. So once it reaches 0, it will switch over from the loop. So now what I have to do? The sum of the value which is in the accumulator is 04H. I want to add the result. So initialize the location where to store. So I have taken the address 4300H. So now the 14 will be, which is in the accumulator, is moved to the 4300H, then halt it. So this is a program to add 5 numbers. So in the 4500 you take the location, give any 5 numbers, rotate this program, it automatically generate the answer, but keep in mind every digit to be added in hexadecimal. So before using the kit we have to convert this program into opcode. So now I am taking the address 4200. So in the 4200 first I have to write the opcode for LXI-H, which is 22. Then I have to give the lower byte address 00, then 45. So 3 address. Then next address is 4200 and 200, 1, 2, 3. So here I have to give MVIB, which is 06, opcode is 06, operand is 05. It need 2 address. So 3 and 4, the next address is 4205. In the 5 I have to give a opcode and operand. The opcode for MVI A is 3E. Then operand is 00. So this is a 2 byte instruction. So next address is 4207. Here I have to give add M, which is 86. So refer the opcode sheet and convert this program into mnemonics. The next address is 4208 because this is a single byte. Then INX-H I have to give, the corresponding opcode is 23. The next address is 4209. So the opcode for DCR-B is 05. This is a single byte instruction. Then I have to give 420A. After 9 the next number is A. So here the next address is 420A. Here I have to give the opcode for JNZ, jump on no 0, which is C2. Then where I have to switch over for ADM. So ADM address is 86, which is 0742. So this is a 3 byte instruction. So A, B, C. So the next address is 420D. So here I have to store the address. STA is 32. Address is first lower byte 00, then 43. So you take 3 address, right, D, E, F. So next address is 4210. So, here I have to give the opcode for halt, which is 76. Okay. This is a way of conversion. Now, this opcode will be entered into the kit and we will check whether the answer 14 comes. So, now I will give the input as sub 4500. The input values are 02, then 03, next 05, next 4, next 6, right, remaining clear it. So, what are the inputs I have given? 4500 is 2, 3, 5, 6, 4 and 6, right. So, input has given, now only you have to execute it. Go, starting address 4300, execute it. Now reset it. Where is the result? 4200. So, before that, what is the expected answer? 6 plus 4, 10, 10 plus 5, 15, 15 plus 3, 18, 18 plus 2, 20. So, what is the equivalent for 20? Yes, 14. Execute the program, go 4300, execute it, reset, sub 4200. Now, the resultant value is 14, sum of 5 numbers, which is 20, hexadecimal equivalent is 14. Okay. So, in the 8-bit addition, we have discussed how to add two 8-bit number with carry and without carry. Along with that, sum of 5 numbers. So, questions: how to read data from 4300 memory location? Write a program to add the given number 1723 with 47 H. Which instruction is used to add to 16-bit data? Thank you.